Yay! Okay, how awesome is YGLF so far? I think the best accomplishment of the day so far was not having to choose what to get for lunch. Okay, so welcome to Managing Animation Sanely in Insanely Complex App. And this is an interactive talk, so we're about to watch an interactive video. What does that mean? That we'll be watching a video together, and that video changes based on viewer choice. So, at one point in this video, one character is going to ask another character something, and 3 choices are going to come up. And you yell which choice you want me to pick. And the one that yells the loudest, that's the choice I'm going to pick. Okay? Ready? Yeah. Okay. One guy's ready.
Check it out.
Oh, sorry. Oh my God. Jill!
Oh my God. Wow, it's you!
That moment when you vaguely remember someone that totally knows you. Help Jill remember just when and where they hung out and what his fucking name is.
It's been a minute, Jill. How are you?
Oh, I'm really good, yeah. And how are you? Tell me anything, everything.
Oh, you know me.
Wait,
Same
right?
old me. Except, you notice anything different about me? One little irregularity.
Which one?
Yes,
It's like a unique, different thing.
Yeah, it's your neck scar.
My scar? Everyone can see how deformed I am. You know, it's no fun being a former conjoined twin.
I'm so sorry.
Yeah.
Okay, so yay. So that was an interactive video, which I personally worked on at Echo. And that's the point where I say, hi, and my name is Opher, and I'm a creative developer at Echo. And you might know me from my greatest hits. Have you tried refreshing your cache? Or don't just add that in X99, that's not going to work. Or no mom, I don't know why your computer is running slow and I can't fix it. So Echo is a platform for interactive videos, which are kind of like a combination between a video game and a TV show. And as such a thing, we put a lot of emphasis on user experience. And that means that our user experience, we consider it a first-class citizens when we design and develop our projects. This type of user experience can be of all sorts of things. It could be like different types of buttons or dragging or motion, all sorts of different things. And because all of this user experience is overlaid on top of moving video, there's an expectation from our users that the interface itself needs to be kind of on the same level. So we can't just use plain old bootstrap buttons or regular form buttons, because that's not going to appear very magical on the video. So we need to push ourselves and the user interfaces that we make so that they give the experience that we want to give our users. And today, I want to show you something that I personally worked on, and that is this little thing on the bottom that you can't see, but you will see in a moment. So, much like in video games, where you have the option to save the progress of the video game, in our projects, we also have something similar. It's called checkpoints. And that means whenever you reach a choice in the story and you make the choice, we save that and allow you to move back and forth between different checkpoints. And that's an interesting functionality to tackle in terms of user interface. So this little thing on the bottom is the user interface that deals with that. So you see you have your next checkpoint that tells you when are you going to reach that. When checkpoint is saved, you have that animation. You can go back in time, and there's this VCR effect and the arrows that lets you actually notice that you're jumping back in time. And the same applies for going forward in time. You have the same like VCR effect, and you have the little animation that shows you that you have more checkpoints to go back with. So there's a lot happening here. There's like SVG animations on the bottom. You have CSS animations. You have a shader that manipulates the video in real time. You have components like for the play button and the different captions. And all of these need to work in synchronized fashion with themselves and with the video. And that brings us to what we're going to talk about today, which is not just managing animations in complex apps. It's about managing animation in insanely complex apps. And I'm sure if you've ever tried to work on animations yourself, you find yourself, okay, I could just move this div from here to there. And then you realize that, okay, maybe it's not so simple. So the solutions that we try to come up with need to be sane, so that when you actually run your code, you can actually manage it and keep working on it in a way that makes sense. Okay, but in order to tackle that, we need to talk about two different things. One is animation, and the other is state. So when I talk about animation, what do I actually mean? So does anyone recognize this thing? Yeah, okay. What's that? It's a video game called Cuphead. It's a platformer video game that its entire animation is modeled after like the animation trends of the 30s. So let's try to zoom in specifically on one of these birds with nails attached to their heads, because video games. So you're seeing a bird flying, but you're not actually seeing a bird flying. You're seeing the different frames of a bird flying. So what you're seeing are actually frames over time. Someone took the time to painstakingly draw the different types of frames, and then when they're played forward fast, your brain thinks this is actual movement. But if we look at this mathematically, then animation is simply a function that takes in time as a parameter and outputs the frame. So at any given point in time, you have a specific frame. But animation has done some progress since the 100 years or so it exists. If you watch a Disney movie, the first time, the second time, the third time, or the fifth time, like me, it will be the same actual movie. Nothing actually changes in the movie. But what we do as front-end developers with animation is different, because UI animation is dynamic. What do I mean by that? UI animation changes based on app data. So if you have different data, if the size of the text is different, if you have more or less images, if one user sees one thing and another user sees another thing, the animation will be different. And it also changes based on user input. So in drag animations on your mobile, for example, where you place your fingers, where you drag them, changes what happens to the animation. In this example, you see that where you put your fingers changes the animation. So that's really different from the classical animation that we see in passive mediums like movies or TV. But animation, we need to remember that it's not just there to be fun and look cool. UI animation is a tool to convey information. So let's see an example of that. Let's take an email client, a web email client, like Gmail, for example, and the action of just composing a message. And, you know, when you press send on a message you're composing, the window goes away. So here it goes away by zipping upwards. But there are other circumstances where this window disappears. So one of these would be if you discard the window. If you don't want to send the message, you're changed your mind. Okay, so here you have different animation that kind of makes the window drop downwards. So the same thing basically happened. You had the model window up, and then you had the model window disappear. But here the animation tells the user that the reason why the model closed is different. here's a more interesting use case where we actually save the draft. So we don't send the message, but we save the draft into the drafts folder. And here the animation is a little more complex because you have the modal window, the actual component of the modal window shrinking down into this section of icons, and the icon for the drafts, I hope you can see it here, kind of pops up to tell the user that, listen, if you're searching for this draft of the email that you just closed, it's going to be there. And this animation has coherency because it happens in a certain sequence. So first you have the modal window closing down, moving towards the icon, and then the animation for the icon starts to do its thing. But if it wouldn't happen in this sequence, it wouldn't make sense. So the order of the animation across these two different components has to be this exact order. You can't just run them in different times. Okay, so let's put animation aside for a second. What is state? And I'm not going to segue too much about state because this talk is not about that, but let's try to kind of understand the problem. Let's say that you're tasked with developing a social network, and let's call it a profile brochure. Okay, so your team, the one that you're on, is tasked with developing this feature of a small chat window on the bottom right. And whenever a user gets a new message, there's a small notification, maybe the header gets a different color, that tells the user, listen, you have a new message that you need to answer or no, depending on how social you are. But on the different side, on another side of the campus, there's a different team. And that team is working on the header of the app. And the feature requires that header to also have a notification whenever a user gets a message. Okay, so you can call them, send them an email, a Slack, or a Telegram, or a mail pigeon, whatever, and tell them, okay, we need to work to coordinate that if someone that uses your feature clicks on the icon, then our feature will also make the new notification disappear. Okay. Oh, but there's a third team, and they're working on a big chat app, so you could look at the big chat app where you're looking at the little chat app. I don't know why, that's what the PM wanted. But that's the feature. And now you have 3 different places where if a user clicks to let the app know that they've read the message, then the new message notification needs to disappear in 3 different places. But the concept of you have a new message is the same for all of them. So that means that the data for the app that says, listen, there's a new message, needs to be saved somewhere. So when I talk about state, I mean the current snapshot of the app data. And from your experience, I guess you probably already know that handling app state is hard. It's not a trivial problem. And that's why when you go and start a new project, you pick one of these squiggly lines to handle state for you. And people really worked hard on those software behind the squiggly lines to make state management manageable. And they all work kind of the same, some implementation details. Don't anyone get offended by what I just said. But the gist is similar to this. You have one place that holds the data, that is the store. You have the view, which is what the user actually sees. So in a browser sense, that would be the DOM. In an app sense, that would be the app components, whatever, the mobile components. And there are actions that happen between the view and to update the store. And this whole vicious cycle continues and continues. But this doesn't matter. If you take one thing away from this talk, is that if you look at this whole state management thing mathematically, you get this. State is a function of an old state and action. That's it. That's the thing you need to remember. That's what the test is going to be on. Okay, let's take our newfound knowledge and try to create some sort of app with this. And the app that we're going to create is this multi-select component. You have a bunch of options, and when you select one, it gets added to a list, and then gets removed from the possible options. Okay, cool. So the data structure for something like this could look, I hope this is readable, but it's an object with two properties. One is the possible options, and the other is the selected options. Okay, and let's go through how this actually works. So user clicks on the first option. The first option gets added to the state. So now we know that option was selected. The Vue renders to update the option that was selected. Okay, the user clicks on the second option. The second option gets added to the state, and the Vue re-renders to let the user know what just happened. Okay, nothing too complicated. But this thing that we just saw, it wasn't even a style. It didn't have any CSS, any animation, anything. Let's add some animation to it. The exact same functionality, but now it looks like this. So you have all these things closing and opening and whizzing down or whatever. It's kind of hard to understand exactly what happens. So let's break this down step by step. Okay, a user clicks on an option. The option gets added to the state, and also the option disappear animation starts playing. This is this little mask thing closing down in a circle. Okay, next thing is the squash animation and the rectangle appear animation. So the squash animation means that all the other options that were below the option that you selected move upwards, and then the rectangle for the new option opens up. So these happen at the same time in two different components or subcomponent of the multi-select list. Okay. Then you have the label expand animation, which is where the text of the new option is. So now you can ask yourself, what happens if the user clicks a few options rapidly? Or to be more precise, what happens when the user clicks a few options rapidly? Because you know users, they don't actually do what you intend them to do. They do the exact opposite thing in the good case and something that nobody expected in the bad case. Okay, so the user clicks on the first option. And the option gets added to the state. Yeah, you have now clicked on sketch. You have sketch in the selected options. Great. And the option disappear animation starts. Great. Only now the user clicks on the second option. The disappear animation is running right now. Okay. Now the second option gets added to the state. So we have that Photoshop option in the state. And okay. Now what? Because the animation didn't actually finish. Rendering an animation didn't actually finish. So what exactly are we supposed to do? There's a tight coupling here between the state and the interface. So you come across, you start asking yourself all sorts of questions like, nobody defined what should happen when such a thing happens, because your designers, your motion artists, they're amazing, but they can't think up every possibility, and you can't code for every possibility. And maybe sometimes the animations target the exact same elements, so one animation tells it to go this way, one animation tells it to go that way, then what you do? Or maybe you need to animate elements that haven't been added to the DOM yet, because the state hasn't changed yet, or maybe you need to animate elements that were already removed from the DOM. And okay, at that point you're like, I'm not dealing with that. And this is what I mean when I say insanely complex apps. They have two defining characteristics. One is that you have multiple rapid state changes in multiple components. So nobody waits for animations to finish. It's just things. People click on things and things should happen. And you're, as the developer, are responsible for somehow patching this whole mess together. And the second thing is that animation can span across multiple components and can be activated at arbitrary times. So again, nobody is waiting for you, the developer, to have a good time. And that leaves us with the crux of the problem. You see, animation is a function of time. It receives time and outputs a frame. But state is a function of an old state and action to receive a new state. animation doesn't care about state. It's not in its scope. And state doesn't care about time. It usually happens instantaneously. So there's no actual connection between the two. And to drive the point home, I want to tell you a little story. You might not know this about me from my exemplary exterior, but I'm kind of a slob, especially when it comes to being at home. And I was at home one day, sitting on the couch in the living room, watching TV. And then my wife comes to me and says, "Listen, Opher, the bathroom could have been in a better condition than it is now. Why don't you go and clean it?" And I mean, I'm sitting on the couch doing nothing. I have no argument against that. So I'm like, sure, yeah, okay. And I go and clean the bathroom. And then I realize that I might have left the living room in not such an orderly state either. So I hear her from the living room saying, "Hey, Opher, why don't you clean the living room as well?" So I have several options at this point, which I would like to demonstrate in a diagram. And this is the first one, where I go to clean the bathroom. And as I'm cleaning the bathroom, I get the request to clean the living room. So one option is that I just simply go there and clean the living room, leaving the bathroom in a less than ideal state. Which means that when my wife gets there into the bathroom, she is not going to be too happy. And if we go back to animation land, then this solution is called skipping. When you have one animation happening, then an action takes place, and then you immediately jump to the second animation. You see with these little rectangles. When you click on the button that says next animation, we just jump immediately to the green rectangle moving right. There's another variation of this, which is skipping with fast forward, which means that when the next animation happens, the first animation jumps immediately to the last frame. So you see here the rectangle just jumping to the last frame, and then the green one continuing. Okay, so the obvious advantage with this is that the animation is always updated relative to the state, because the state changes instantly, and then you jump to the animation to fit the new state. But obviously the disadvantage here is that you might get like a janky animation where things jump all over the place, and then it's not presented as intended. Okay, here's the other option, where I go to clean the bathroom, and then I get the request to clean the living room, and then I just finish there, and only when I finish do I go and clean the living room. Okay, but the thing is that when I finish everything and come back to the bedroom 5 hours later, we're not going to be watching Game of Thrones, and that's not going to leave her too happy either. And in animation land, that solution is called queuing, which means that you have your animation. The action takes place during one of the animations, and then you just queue on the next animation so that when the animation that's currently playing finishes, only then the next animation plays. Okay. The advantage here is that animations flow fluidly from one to another. But the disadvantage is that the animation will always play catch-up to the state. Whoa, animation. So the state has already changed by the time you reach the animation that actually tries to convey to the user the information of what state just changed. Okay, there's this third option, which is that I go into the bathroom and start cleaning it, and also go back in time and clean the living room at the same time. But you know how time travel is. It's complicated. And if the Opher from the future touches the Opher from the past, the whole space-time continues get destroyed, and that's not going to pan out too well either. And yes, I realize my metaphor at this point completely breaks down, but bear with me. The third solution in animation land is additive animation, which means that both the first animation plays and the second animation at the same time. And that's kind of hard to understand this format, so let's say that we have this blue rectangle. And one animation tells it to move right. And the other animation tells it to move upwards. So the sum, the addition of these animations is the rectangle moving to the top right. Let's see this in action. Let's say that every time someone clicks on the page, then the rectangle moves to where the mouse was clicked. So in skipping mode, it'll look kind of like this. You click somewhere, and then the rectangle stops and goes to the new place. In additive mode, it means that you have these little nice arcs. Okay, so that's additive animation. And the pro here is that it seamlessly joins to animation in a natural way, but it doesn't always work for all of the different components or different types of animations, because sometimes you can't really match two animations that don't work together, like opacity and size. Okay, the first type is that I go to the bathroom and start cleaning it, but also lock the living room. So no matter how many times my wife tries to get there, she will not be able to, because it's locked. So she won't be able to tell me to clean it. Yeah, she's not going to be too happy about this either. And that solution is called limiting access to the UI. That's not an actual solution, this is just abusing your users. So if you can, please avoid doing that. Okay, so the pro of this is that we'll make your designer and PM happy, but your users cry. Which one should you pick? The answer is that it's all about managing expectations. If your app is really important to show data in real time, then maybe skipping is the way, because it tells the user the proper information at any given time. But if your app is all about fluidity and user interface, then maybe queuing is the right way. Okay, so let's start to untangle this mess. How do we actually solve this? So we saw this model earlier with the store state view, and I propose this, the animation orchestrator, which is an entity that is tied to a view. So whenever a view updates, it lets the animation orchestrator know what just happened, and that updates the view. And if you have several views, you have one instance of this animation orchestrator, which kind of takes care of the different animations and queues them or skips them or does whatever it is that it needs to do. Okay, how would you go implementing this? So really quickly, it doesn't matter if you're using Angular or React or Vue. I do recommend using a library called GreenSock, which is like a low-level library that deals with animation. It lets you do animation in JavaScript with a really nice, robust API. And the specific implementation feature that you need to use is animation timelines. So animation timelines is a feature that lets you kind of animate different elements, but because it's on a timeline, then animation is defined at any given point in time. Okay. But this is the low-level tool, so it doesn't actually deal with state or anything. So today, I am super happy to announce the release of a new open source library I've been working on for quite some time called React Animation Orchestrator. And React Animation Orchestrator is an implementation in React of the features of the ideas that you just saw here. And it is in React, but if you want to collaborate on something like this in Vue or in Angular or whatever, I'd love to hear from you, so we can talk afterwards. So how much time do I have left? Is that right at all? Okay, so I'll skip shortly on how to work with this and go directly to the demo. Okay, so let's do that. Not this one, not this one. This one. Okay, so this is what you saw before. The animation is slowed down here so that you can understand what's going on. So you see I click on this, then I click on this. Then I can click on this. And animations here are queued so that is taken care of for you. And one thing that I do want to show you is that let's say that you want to change this to a skipping mode. Here it's called interrupt. Then if I do the same thing, you can see that the animation skipped to the end of the previous animation, and that the library did it all for you, and you don't have to actually take care of that, which is pretty cool. Cool. So let's skim through how to do actually. All the things that you just saw are available on the demo as well on the repo, which I showed earlier, and the link to the slide will be there as well. Skip, 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 skip. That was the demo. And just quick recap. So we saw the problem is that animation is a function that takes time and outputs frames, and that state is a function that takes an old state and a new state, and the two don't work together. So the possible solutions are cutting and skipping, queuing, and additive animation. And there's also the animation orchestrate if you're interested. So thanks. But I want to leave you with one last thing, and that is the Pac-Man rule. Have anyone ever heard of it? Cool. So it's a rule by Eric Holscher, and because we want to have an inviting and an inclusive, not exclusive, inclusive conference, then I heartily recommend showing people explicitly that it's okay to join group. And how do you do this in the conference? If you're standing around in a group, then that's not inviting for people. So just make a little Pac-Man mouth and let people walk into your conversation, and then make sure to create another little Pac-Man mouth so that everyone can feel invited to join the conversation. This amazing animation was done by Deal and Biddy. Thank you so much.